In this section of section 1.5, we'll be talking about rational exponents. Think of rational exponents as fractions, and they're going to be in the exponent spot. So we're talking about like 2, and then the exponent would be like 1/3 a fraction, or 8 to the 1/3, or 27 to the 3/5. Okay, so the exponent is a rational number, and that just means it can be written as a ratio of two integers. And so let's take a look at the two rules. Oh, in a second. First, we're going to pull up our calculators, just see our calculator evaluate this. So I'm going to grab my Desmos, get my scientific calculator. And so if I want 4 to the 5/2 power, I'm simply going to press the 4 on my calculator, the A to the B button. Now my fraction is 5/4, so I got to make sure, or 5/2, 5 divided by 2, I got to make sure that's all in the exponent. Let me blow that up just a little bit so you can see it's 4 to the 5/2, and you can see my answer is 32. So clearly exponents, even when they're fractions, they have meaning. So this is equal to 32, and as we go forward, we'll discuss where we get that from. Now, our book gives us two rules. I had alluded to those before, right there, 4 to the 5. And they're basically the same thing, except for one, you'll notice the exponent, again, is a rational number, m over n. And the other one is the same thing, except it's got a negative in front of it. So I'm going to blow both of those up on the next couple of slides, and we'll examine each one individually. I think it's the problem we had here, over 2, and you'll see me break here to see. And so here is the first one, and let's kind of look at that in close detail. It says a to the fraction exponent, m over n. So m is our numerator, n the denominator in the exponent, is equivalent to a to the 1 over n. So our denominator is still n, but they put the numerator on the outside. Now, the rule for exponents here is multiplication, so 1 times m is m. This is still m over n. We've just factored this m out of that. And then finally, this is from our first day, and a to the 1 over n is the same as an nth root of a. Okay, so I'm going to take that first original bit down here. And so our first step is, note we keep our a, base is still 4. We write to the 1 over our n value, for us that's 2. And we take the 5 as an exponent on the outside. And lastly, we change this 4 underneath the radical. So there's our a, and our a is now under the radical. And our n now, the index is that 2. So it's a square root, then parentheses, and it's to the 5th power. And now we can evaluate this thing, the square root of 4. Now remember, we usually don't show a 2 there when it's square root, but I'm trying to emphasize that that denominator in the exponent is the index of the radical. So the square root of 4 is just 2. So it's 2 to the 5th, and 2 to the 5th is 32, exactly what our calculator gave us. Let's apply this to the next problem. Same idea. So we're going to rewrite this as 16 to the 1/2 power raised to the 3rd, which is the square root of 16 raised to the 3rd power, which is 4 to the 3rd power. That's the square root of 16, and that gives us 64. And our very last one, 1 to the 7/8 is the same as 1 to the 1/8 raised to the 7th power, which is the 8th root of 1 raised to the 7th. Well, 1 is 1 times itself 8 times, so The a through to 1 is just 1, so it's 1 to the 7th power, and 1 times itself 7 times is just 1. So there we go, just using that first definition here for what rational exponents mean, fractional exponents. That's how we go about simplifying these expressions by hand. Again, our calculators would do this for us, but these are ones that we should definitely be able to do without a calculator. Okay, the second statement in that core concept dealt with what happens if our exponent is a negative rational number, or a negative fraction, if you will. And it's pretty much the same thing, except notice this first step. This negative exponent means to take a, the base, move it to the denominator, and make it a positive m over n. And so you can think of this as already being all over 1, because every number by themselves is over a 1. And so when I move this down to the denominator, I have to indicate it's in the denominator by putting a 1 on top. After that, this denominator, we just simplify like we previously did. We separate out that m, we just factor it out. Then we can change this 1 over n to a nth root of a. So let's watch this in practice on our first example here. And our first step is to rewrite it as 1 over 32 to the positive 3/5. Then we factor that 3 out, so it's 32 to the 1/5, all to the 3rd power. That's 1 over the 5th root of 32, and then raised to the 3rd power. And so now we're ready for our last step. Well, almost our last step. The 5th root of 32 is 2, and then we have to take it to the 3rd power. So this is all equivalent to 1/8. And our last example, let's move it to the denominator and make it a positive 3/2. Let's factor out that 3 by rewriting it as 1/2 exponent to the 3rd power. Change that half to a square root, because that's our index, remember, the denominator of the exponent. Square root of 9 is 3, and then I have to cube that 3. So I end up with 1 over 27. Short notes, but there's only 2 types of problems, really. Let me zoom out so you can see all of these, if you want to take a screenshot of that real quick. And these are your problems, and you can see here we've got, like in number 1, okay, we're going to write that as a 6th root, a cube root, a square root, because of that too. Then we're going to have to cube it. Okay, here we've got going to have to cube root it and take it to the 4th power, negative exponent, so we got to put it all underneath a 1 over 8 to the 2/3. Same thing with number 9. There's a few more problems down here so you can see them all. But your assignment, very much like the examples. I'll put little stars next to the ones. These are like example number 1. And these are then, the other ones are like the second page of examples with negative exponents. That should help you out a little bit. That's it.